All right, square root for today, and basically what we're trying to find out. First of all, a symbol that you'll see when we're doing square root is this thing right here, and that's actually called a radical, or a radical symbol. So what we're looking for when we find a square root, whatever number is inside of that square root, we're looking for the answer to be a number that when you times it by itself, you get what's underneath this radical symbol. And remember what that means. If you times something by itself, that's like taking it to the second power, and we say squared. So we need a number that multiplies by itself, which is a number squared, to get what's underneath the radical symbol. What I have here is a list of square roots that we call perfect squares, or perfect square roots. Basically what this means is when you find the square root, the number comes out whole. So let me give you an example. The square root of 1 is 1. And if you think back to that last board I had up there when you wrote your notes down, what we're looking for is a number you could times by itself to get on the inside of the radical symbol. 1 times 1 is 1. Square root of 4 is 2 because 2 times 2 is 4, or 2 squared, 2 to the second power is 4. Over here we've got 3 times 3 is 9, so the square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. And all the way up to the square root of 144 is 12. I would suggest, and not suggest, do it, in your notes, write down these first 12 perfect squares. Having this list is going to help immensely for the next thing that we do. So please go ahead and write down these perfect squares before you go on to the next part. Here are 4 problems that you can try by yourself if you already know what you're doing, and if not, you can kind of pay attention and I'll kind of talk you through these. The answers to every single one of these are perfect squares. They come out whole. You should be able to find a number that when you times it by itself, you get what's underneath the radical symbol. So if you want to try these by yourself, do it. If not, just follow along with me. The square root of 10. So we need a number where we can times by itself, or we need something to the second power where we could times it by itself to get 100. I know that 10 times 10 is 100, so my answer is 10. 10 to the second power is 100. Remember, 10 to the second power is the same thing as 10 times 10. So my answer, if the question was, what's the square root of 100? My answer is 10. Coming down here, square root of 16. I need 2 numbers that will multiply by themselves to get 16. I know that 4 times 4 is 16. So when I put this up here, my answer is 4. 4 times 4 is 16. The question is the square root of 16. Your answer is 4. Coming up here to 25. What I need for 25 is I need a number that you can times by itself to get 25. My answer is of course going to be 5 because 5 times 5 is 25. Now the last one is 400. This one we did not put on your list, but we will eventually. There is a number that you could times by itself to get 400. That number is actually 20. If you do 20 times 20, 20 times 20 is 400. I'm going to show you how to find square roots that do not come out evenly, do not come out whole. Let's take the square root of 72 for example. There is not a whole number that you could multiply by itself to get 72. Okay, there's not one. So in this case, the answer is going to be a decimal, but we're not going to figure it out that far yet. All I'm asking is to know what 2 whole numbers would the square root of 72 be between. So how we're going to do this is not too hard, I don't think. I want you to think about what would the perfect square roots be around 72. So you can always refer to that list until you get comfortable with these. But what perfect squares are around 72? And here's your answer. The square root of 64 is a perfect square that's just below 72. The square root of 81 is a perfect square that's just above 72, and this one's below 72. So now we know that the square root of 72 has to be between whatever this answer is and has to be between whatever this answer is. The square root of 64 is, of course, 8, because 8 times 8 is 64. The square root of 81 is, of course, 9, because 9 times 9 is 81. So the question is, between what two whole numbers does the square root of 72 fall? And the square root of 72 is between 8 and 9. And if you actually did this, like took a calculator and you typed in 72, and then you had a calculator that had the little square root key, your answer is going to be 8 point something, okay? Because 8 point something would between the whole numbers 8 and 9. Alright, square root of 10 is definitely not on our perfect squared chart. This is not going to come out whole. There is not two of the same whole number that we can multiply together to get 10. Okay? I want to know between what two whole numbers does the square root of 10 go between. So in order to do that, we need to figure out what is the perfect square just below here, just below where the square root of 10 is at, and what is the perfect square just above. And it's got to be the one that's just below and just above, because we want a range of two numbers. We want between this, and we want them to be right beside each other. So if you refer to your chart, where would the square root of 10 fall into? Well, for starters, the perfect square below it is going to be the square root of 9. The perfect square above it off your list is going to be the square root of 16. So now we know that the square root of 10 is going to come between whatever whole number this is and whatever whole number this is. So let's figure out what this is. The square root of 9 is going to be what two numbers multiply together to get 9 that are the same number. I know that 3 times 3 is 9, so we know that 3 is on the low end here. Over here, we know that 4 times 4 is 16. The square root of 16 is 4. So our answer to the question, between what two whole numbers does the square root of 10 fall between? And our answer would be 3 and 4. And again, if you did this on a calculator, you would get, I bet, probably 3.1 something something something. Okay, 3.1 is between 3 and 4. All right, last example I'll give you here, the square root of 39. That is not on our chart for the whole numbers that come out whole. I need to find which two square roots are perfect squares, are right around square root of 39, so we can see what two whole numbers the square root of 39 is between. So I need the perfect square that's just below 39. So if you need to refer to your chart, do that, that's fine. But if you look at your chart at your perfect squares, you can see that the square root of 36 is the one just below square root of 39. On the high end here, just above square root of 39, I believe would be square root 49. Now we have to do to figure out what two whole numbers the square root of 39 is between, because it won't come out evenly, is figure out what the square root of 36 is and the square root of 49 is. Square root of 36 is, of course, 6, because 6 times 6 is 36. Square root of 49 is going to be 7, because 7 times 7 is 49. So our answer is going to be, what is the square root of 39? We're going to say between 6 and 7. If you did this on the calculator, your answer would probably be 6 point blah 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 blah. 6 point blah 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 is between 6 and 7. Alright, what I want you to do is take some time and figure out where the square root of these numbers would be. Now, some of these are perfect squares, meaning they're going to come out perfectly. You're going to have one number for an answer. Some of them are not perfect squares. they're going to come out to be between two whole numbers. I'll give you a hint. 2 of these are perfect squares. 2 of these are not. If you're comfortable at this point, why don't you pause the video, try these problems on your own. If you're not, you can always kind of watch through this part and see if you can figure it out. Alright, let's see how you did here. I'm going to start with the ones that do come out perfectly. Answer to square root of 4 is 2, because 2 times 2 is 4. 2 squared is 4. This is the other perfect one. 11 times 11 is 121. 11 squared is 121. So opposite, 121, the square root of 121 is 11. Now the other two, we're going to have to come up with numbers that they fall between. Okay, so here's what we're going to do for square root of 2. I need the 2 perfect squares that would be on either end. So I know that the one on this side would be the square root of 1, and the one on this side would be the square root of 4. And all I'm doing is looking at the chart that we wrote down of perfect squares and seeing that square root 1 is on the chart, square root 4 is on the chart, 2 would be between 1 and 4. So now I need to figure out what whole numbers we have. The square root of 1 is obviously 1, because 1 times 1 is 1. The square root of 4 is 2, because 2 times 2 is 4. Now my answer is going to be somewhere between 1 and 2. If we come to this example, square root of 27. Again, there's not two numbers that are the same that I can multiply together to get 27. So I've got to do what's around it. And what's around it would be the square root of 25 and the square root of 36. 27 fits between 25 and 36. The square root of 25, of course, is 5. 5 times 5 is 25. The square root of 36 is 6. 6 times 6 is 36. So my answer to this question, square root of 27 would be between 5 and 6.